Chapter 2 starts with rational expressions. Now, do you remember learning about rational numbers? A rational number is any number that can be written as a fraction. Oh no, fractions. And rational expressions are the following form. A over B. Whoa, that again looks like a fraction. It's true, people. This whole chapter has lots to do with fractions. But we're talking fractions at a whole new level. Because A and B are not just numbers like 2 over 3. Now they're both polynomials. So a polynomial could be a monomial, binomial, trinomial, 4 terms, 5 terms. Usually it's either going to be a monomial, binomial, or trinomial. So an example would be something like 2x over x squared plus 3. Okay, that's a rational expression. It's a over b, where a is 2x and b is x squared plus 3. Another example might be something like x squared plus 4x minus 2 all over 3x squared minus 2x plus 4xy plus y squared. So in this one we had a monomial over a binomial. This one we have a trinomial over a 4-term polynomial. It can be anything. It could be a trinomial over a trinomial, binomial over monomial, whatever. Okay? Now there's one very, very important restriction here with a and b. You can probably guess what it is. B cannot equal 0, right? That would mean you'd be dividing by 0, and you're not allowed to divide by 0. Why are you not allowed to divide by 0? Well, I know I told you before, so I'm not going to go through the whole song and dance. Let's just stick with this. Take that as a warning. Just don't do it. Okay, now if you can't divide by 0, it means we have to worry about things which are called undefined values. And what this is when you have a variable, an x, a y, or whatever, in the denominator. Okay, if there's an x, like right here, 7x in the numerator position, this x can be anything, right? It doesn't matter. X can be 0. Who cares? 7 times 0 is 0. That's fine. You can do 0 divided by something. You just can't divide by 0. So you end up getting undefined values if you have a variable in the denominator. Undefined values are also called non-permissible values, or NPVs, and I tend to call them that because it's such a catchy name, NPVs. And they occur in any value that makes the denominator equal to 0. So we're going to find the NPVs, or the undefined values, for these examples here, these expressions. So the first one here, 5 divided by x. Pretty simple. What can x not be? Well, the denominator can't be 0, so x cannot be 0. Alright, that was no problem. Next one. Again, it doesn't matter what the x is in the numerator. Even if it's 0, it'll still work. On the bottom, a lot of time people say, oh, there's a variable on the bottom, so x cannot equal 0. That's not true. X can equal 0 in that case. 0 take away 2 is negative 2, and it's totally okay to have negative 2 on the bottom. What you can't have is the whole amount equal to 0. In other words, x minus 2 cannot equal 0. And even though it's a cannot equal, is unequal to sign, you still solve it just the same way you normally do with equations. Add 2, x does not equal 2. So this is your non-permissible value. X does not equal 2. Okay, now I need to say something here because otherwise when you do your homework you're going to get all confused. There's another way you could give the answer. And what the other way would be, so I'll put or x is undefined when x equals 2. So I like this. This is saying that x cannot equal 2 in this expression. But to me that's makes a lot of sense. But when you look in the back of your book, I think what they would have as their answer is this, x equals 2. I don't like that answer. But the reason they have it is because they're telling you that this is the x value, 2 is the x value for when x is undefined. It doesn't mean that x can equal 2. In fact, x can equal 2. Because if it was 2 here, it'd be 2 minus 2 is 0, and you'd have 0 on the denominator. You can't do that. So I'm just alerting you to the fact that there's two ways to represent this. One way to represent it, which I like, is x cannot equal 2 in this case. That's the non-permissible value, or the undefined value. Another way, which you'll see in the back of your book, is x equals 2, and all they're saying there is that the non-permissible values, or the undefined value, is equal to 2. But personally, I don't like that method so much. Alright, next one. We need to know, first of all, numerator never matters, so it's just the denominator. We need to know what would make x squared minus 6x plus 8 equal to 0, because it's not allowed to be 0. It cannot equal 0. Now, this is a quadratic. Remember how to solve quadratics? We did this in the last chapter. You're going to make it equal to 0, or not equal to 0 in this case. You're going to factor. So, This is a simple trinomial. We're looking for two numbers that multiply to 8 and add to 6. 1 and 8, 2 and 4, that's it. So it must be this one. Those add to 6. So we've got x and x. 4 and 2 are our numbers. Drag down that minus. Negative times a, negative equals the positive, and it cannot equal 0. Now, we use the zero product property. If this times this equals 0, or in this case doesn't equal 0, what would make it equal to 0? Either if this, x minus 4, equaled 0, or this, x minus 2 equals 0. In this case, we don't want it to equal 0, so we'd put it like that. Add 4 to both sides on this side, you get x does not equal 4. X is not allowed to equal 4. Add 2 to both sides here, you get x is not allowed to equal 2. Again, why is x not allowed to equal these two amounts? Because if you put 4 in here, you're going to end up with 0 on the bottom. If you put 2 in here, it's going to equal 0. Can't have that. These are your non-permissible values, or undefined values. Alright, last one. On the top, it doesn't make any difference what the numerator is. So we just look at the denominator. And we want to know what would make this denominator equal 0, because it's not allowed to equal 0. How do we solve a quadratic? We factor. This is a difference of squares. It's a binomial. So again, you need to know how to factor in this course. So if it's a difference of squares, what times itself equals x squared? X. What times itself equals 36? 6. Make one positive and one negative. Doesn't matter the order. I'll do it like this. So either x plus 6 is equal to 0, and we don't want that, or x minus 6 is equal to 0, and we don't want that. So we solve both of those. Not sure why I put that in brackets. Subtract 6 from both sides there, you'll get x equals negative 6. Add 6 to both sides here, you'll get x equals 6. Or you could just put plus and minus 6. There's two answers there, positive 6 and negative 6. So those are your non-permissible values. Okay, we're going to do the same sort of thing here. We're going to look for non-permissible values, but we're also going to simplify. So what I mean by simplifying is basically put it in lowest terms. If I give you a fraction like 4 over 10, and you give that as your final answer, I wouldn't be overly impressed. I'd want you to divide them both by 2 and get 2 over 5. So we're going to do something similar to that, but with more complicated things with these polynomials. So there's 3 steps. You're going to factor both the numerator and the denominator. So lots of factoring. You're going to look for the non-permissible values, the NPVs. You must do this in this order, by the way. And you're going to cancel out any common factors. You have to do step 2 before step 3, and I'll show you why in a second. Okay, step 1, we're going to factor numerator and denominator. The way we always start factoring, if we can, is greatest common factor, and we can take out a 2 there. So we have 2, and what we're left with inside is x plus 5. Nothing else we can do. Let's look on the bottom. We can take out a 6 down here. And what we're left with is x, because 6 times x is 6x, and 5, because 6 times 5 is 30. Great. Don't cancel out yet. Now what we do is we look for the non-permissible values. For the non-permissible values, we only have to look at the denominator. So the NPVs, we look at the denominator. 6 times x plus 5 cannot equal 0. We can't have the denominator equal 0. So how would you solve this? Well, this is 6 times all that, so you could do the mountains right now, but I'd probably just divide both sides by 6. You can do the mountains if you want. Dividing this by 6 just leaves you with 1 x plus 5, or just x plus 5. And 0 divided by 6 is still 0. Now I subtract 5 from both sides. I get my non-permissible value is negative 5. X cannot equal negative 5. Okay, step 3 is to cancel out any common factors once we have done the factoring, and there is a common factor. There, that's gone. So what we're left with is 2 over 6. Or, just like we talked about before, I don't like that answer so much. I like 1 over 3. That's the answer. But notice, if you did this first, if you did the canceling out first and got to this stage, you'd think that's the entire answer right there. You'd think that no matter what value you put in for x here, you always get the value 1/3. That's a simplified version of it. But that's not true. There's one value of x that you wouldn't get 1/3. Which value of x is it? It's negative 5. Because if you put a value of negative 5 in top and bottom, you get 0 in the bottom, and that doesn't work. So your complete answer has to be 1/3. In other words, no matter what value you put in here for x, if I put 7 and 7 in there, or 12 or 12, or negative 1.5 and negative 1/2, you're always going to end up with the amount 1 over 3. Try it if you want. But if you were to put x is negative 5 into there and there, it wouldn't work at all, because that's a non-permissible value. You'd end up with 0 in the denominator. Alright, moving on. Same sort of thing. We're going to follow those three steps: factor, MPVs, and cross out common factors. So we factor first of all. There's nothing we can do on the top, so I'll just rewrite it. On the bottom, we have a difference of squares. We did this exact one on the other page, so you should be okay with that. X times x is x squared. 6 times 6 is 36. Plus and minus, or minus and plus, doesn't make a difference. Don't cross out yet. You have to get your non-permissible values. So for the non-permissible values, look, the reason we do the factoring first is you don't want to look back here to get your non-permissible values. If you were, don't write this down. But if you were to get your non-permissible values here, guess what you'd end up doing again? You'd end up factoring again. So you might as well use the factored form to get your MPVs. So what we know for the MPVs is that x plus 6 times x minus 6 on the bottom cannot equal 0. Well, with the zero product property, either x plus 6 could equal 0, and we don't want that, or x minus 6 could equal 0, and we don't want that. Subtract 6 from both sides, x cannot equal negative 6. Add 6 to both sides, x cannot equal positive 6. Or if you want, x can equal plus and minus 6. Anything to cross out? Yes, I can cross those out. What's left up here? Has to be something. 1. So my final answer is 1 over x plus 6. And that'll work for any value of x you plug in here. You're always going to get, any number you plug in here, it'll always be equal to this amount, except if you were to put plus or minus 6. You cannot have those values. So that is what the answer is. Next one, factor. On the top, 4 and x plus 2. On the bottom, 2 plus x. Okay, now we get the MPVs. Only have to look at the denominator. So 2 plus x cannot equal 0. Subtract 2, x cannot equal negative 2. Okay, anything to cross out here? Boy, these two things look very similar to each other. X plus 2, 2 plus x. Can we cross them out? Are they exactly the same as each other? Yes. When you add, order doesn't matter. So, if you want, try it. Put 7 in there. 7 plus 2 is 9. 2 plus 7 is 9. So it's the same amount. You can cross those out. So all we're left with is 4. Our answer is 4. But x cannot equal negative 2. You put any value you want, any number you want into the x, this x and this x, you're going to end up with 4. But not if you put negative 2 into that x and that x, because you'll end up with 0 on the bottom, and you can't have that. Okay, next one's pretty similar. You're going to factor the top, so you'll get 4 coming out as a greatest common factor, and you're left with x minus 2. And on the bottom, you have 2 minus x. We'll get the MPV now. So 2 minus x, the denominator, cannot equal 0. I think what I'll do is I'll move the negative x to the other side, so it becomes positive x. So x cannot equal 2. Alright, can we cross this off and this off? Well, not exactly. Kind of. Does x minus 2 equal 2 minus x? No. Order matters when you subtract. So let's just say, in case you don't believe me, let's say that x is 5. So what we'd have, I'll put it over here, I'd have 5 minus 2 on top, and on the bottom I'd have 2 minus 5. Well, 5 minus 2 is 3, and 2 minus 5 is negative 3. And 3 divided by negative 3 is negative 1. Okay, let's try another one. Let's put 0 in there for x. So it would be 0 minus 2 on the top, and 2 minus 0 on the bottom. 0 take away 2 is negative 2, and 2 take away 0 is 2, so you end up with negative 1 again. In fact, this will always happen. If you're subtracting the same values but in the opposite order like this, you can cross them out, but you can't just say that's it. You have to say what I'm left with is negative 1. So you need to multiply by negative 1. Okay, if you do that, you get 4 times negative 1, which is negative 4, and we already said that x cannot equal 2. So that's our answer there. Last one of these type is same sort of thing. We're going to factor the top by taking out a greatest common factor. Can we take out a greatest common factor on the bottom? Regrettably, no. So how do we have to factor this? Bobby Bridge. So build our bridge. We're looking for two numbers that multiply to 20. 2 times 10 is 20. And subtract to 1. There's a 1 there. 20, that's 1 and 20, 2 and 10, 4 and 5, and that's it. They need to subtract a 1, so those are our numbers there. So we're going to decompose that middle term. We keep the first one the same. We need to have more positives, so we better make it plus 5x, take away 4x, and we rewrite the minus 10. Pair them up. Greatest common factor of the first two is x, and you're left with 2x plus 5. I see a minus sign, so I'll write that down. Greatest common factor here is 2. and I'm left with 2x, be careful, plus 5. Why is it plus? Because a negative times a positive equals that negative. It worked. We have the same thing, which is 2x plus 5, and we have x minus 2 in the other bracket. So we now know that on the bottom here, once we factored all this, we would have 2x plus 5 and x minus 2. Remember, we got to get the MPVs. So MPVs, we take this denominator, 2x plus 5 and x minus 2, and it's not allowed to equal 0. So either 2x plus 5 equals 0 and it's not allowed, or x minus 2 equals 0 and it's not allowed. This one's very easy to solve. Add 2 to both sides, you get x equals 2, or x doesn't equal 2, not allowed to equal 2. On this one, I'll take a couple steps. First of all, I would subtract 5 from both sides. So 2x does not equal negative 5. Then I divide by 2 both sides. So x cannot equal negative 5 over 2, or negative 2.5 if you want. Okay, back here, anything to cross out? Yes, you can cross that out. There's nothing else we can do. So we're left with the answer 3 over 2x plus 5, where x cannot equal 2, and also cannot equal 5 over 2. Okay, this is a simplified version of this one. Couple common errors. If you want to see more than the ones I'm going to show you here, take a look on page 51 of your workbook. At least it used to be page 51 of the version I was using when I made this video. It might have changed. So this is a very common mistake. If you have something like this, x plus 2 over x, people get all excited about canceling stuff, and they want to cancel this and this, x on top, x on the bottom. You can't do that. The reason you can't do that is because this is a binomial on top. You can only cancel binomials with the exact same binomial. So you can't cancel this. If you think, I think you can cancel that, let me show you that it doesn't work. Let's say that x is 4. You'd have 4 plus 2 over 4, right? I just replaced those x's with 4. What does that equal? Well, 4 plus 2 is 6 over 4. That's the same as 3 over 2. Now I'm going to write the exact same thing down again. If you think you can just cancel those out, since they're the same, you're left with the answer 2. And those two things are not the same as each other. So this is wrong. You cannot just cancel like that. As I said, it has to be the exact same binomial. If you had something like this, x plus 3, x over x plus 6. Again, some people try to cancel this, but you might have learned from up here you can't do that. Can you do this? Whoops, I'll use a different color. Can you do this? 1 and 2. No, you can't do that either. It's the same mistake you just made up there. Don't do that either. You can only cancel a binomial with another binomial. So if you had something like x minus 4 over x minus 4 squared, let's say that, then you could cancel. You could cancel this out, and there's two x minus 4s down here, so you'd cancel one of them out, because this is the same as x minus 4 times x minus 4, right? So I'd cancel one of them out, and what I'd be left with is 1 over x minus 4. My point is you can only cancel binomials out if it's the exact same binomial on the bottom. Same with trinomials. I'm not going to be able to cancel this out, x squared plus 2x plus 9. I can't factor that. The only way I'm going to be able to factor that is on the bottom. The only way I'm going to be able to cancel that is if on the bottom I have another x squared plus 2x plus 9. If it's just x squared plus 2x, I can't cancel. If it's x squared plus 2x plus 8, I can't cancel. If it's just x squared on the bottom, I can't cancel. It has to be the whole trinomial the same. What if it was this, 5x over x? Can I cancel that? Yes, I can. This is a monomial over a monomial. No problem. I could cancel those x's out. I'd be left with 5. But be careful, what's the non-permissible value there? You'd have a non-permissible value of 0, because x cannot equal 0, or you'd have the denominator equaling 0, and you know that's not allowed.